Hi, Algebra 1 students. Okay, so this will be part of the I Should Not Be Alive lab, Module 1, Steps 1 and 2. And this is all about using slopes and Y-intercepts, interpreting graphs, and things like that. So what we have to do is on your worksheet, you have, on here, you have a set of questions. Right, so if you go to step 1 and look at the practice problems, you're going to need to do that when you go through this video. So go to step 1 and look at the practice problems. You'll see 3 graphs. All right, it says there are 3 graphs, and you have to answer these questions for problems 1 through 3. I'm going to go over one of them with you after I do an example, and then you'll do the rest of them. Okay, and then we'll go from there. So here's an example to start. And this is very similar to 2 of the problems on there. It says here, suppose a car is driving northeast at 2 miles per minute. And that's 120 miles per hour. You multiply by 60. Okay? So don't forget to do that. If you have miles per minute, multiply by 60 to get miles per hour, just so you can kind of get a context that he's going pretty fast. And a police car gets radioed about the car at time x equals 0. So here is, on here is the police car, and then if we look down here, this is when time equals 0, the car is a certain distance away from the police car. This is distance over time. So if you look at this particular set of points right here, police car is at 0, 0. He's kind of the center of everything. And then the car is going to be a certain distance away from the police car, but they're both at time equals 0 right now. All right. It says here the car is 8 miles south of the police car at that point. So it tells you that. So if you go down -8, okay, that's why it's negative, because it's south. So 8 miles south of the police car, that's where he is. So our Y-intercept then is 0, -8. So it says here, how can we draw a graph of the situation? We know that the slope is +2, because it was 2 miles per minute, and it's traveling northeast. So in directional wise, that's how it determines how you determine whether it's positive or negative slope. So it's positive slope because he's going northeast, and it's 2 miles per minute. So if you look at that, that's up to over 1. Okay, up to right 1 specifically. So again, we also know that the Y-intercept is 0, -8 because the car is 8 miles south of the police car at x equals 0, at time x equals 0. So how do you graph this? First, graph the Y-intercept. So we start by graphing on the Y-axis, -8. That's where the car is, right? And then we use our slope to get the next point. Kind of talked about this last week. So we have to go up 2, right 1, because remember, the slope here is 2 or 2 over 1. That tells me to go up 2, right 1. So that's what we did, and then they put a point. Okay, and then you could draw a line through that, but you could also keep putting more points if you want to see something, if you want to see more of a line instead of just the 2 points. You can do that again. Start from this point and go up 2 over 1. Put another point. And then go up 2 over 1. Put another point. And you can do this until you end up seeing where it crosses the x-axis. And it crosses there at 4. That's 4 right there. If this is 0 through 5, then that one's going to be 4. And it's kind of hard to see, but if you can look on, you can also see this example on your worksheet. That'll give you so interpreting the graph. So it says we can see that the X-intercept is 4. This means that the car passes the police car 4 minutes after he gets radioed. So in 4 minutes, that's the time, they're going to be right next to each other, because at this point right here, the distance, the Y value of these 2 points is 0, meaning that they're passing each other, basically. Like the speeding car is passing the police car. So yeah, so that's how you do that kind of thing. So I'm going to help you answer one of these, okay, one of these, and then you're going to have to kind of do the other two, all right? And you can always look at the examples on step 1. So it says here, for the graph, and you're going to have to look at this as we do this, go to step 1 and look at the practice problem number 1. Okay, so it asks, what's the Y-intercept? So if we look at the actual graph, I know you can't see it on this video, but you're going to have to be looking at it on your computer. If you look at that, the Y-intercept for that particular one, so we can say Y-intercept, is 0, -8, okay? And what that means, again, is that the car is 8 miles south of the cop. Because there's that police car on that particular graph. All right, so that's the Y-intercept. Then it says on there, what's the X-intercept, and what does that mean? So the X-intercept on that particular one ends up being, if you look at that, it's right halfway in between 0 and 5, which means that's 2.5, comma 0. So that's as you graph it as a point. All right, and so that means at 2.5 minutes, because remember the time is in minutes, the speeding car or the car passes the cop. All right, so that means. And then it asks, what is the slope? And what does that mean in terms of the context of the graph? So the slope, if you look at the slope, it's going, if you look at where it's hitting 2 points, 2 grid points, you can kind of see that it goes up. Like if it was 1, 2, 3, 4, 5, it goes up 3. So it was, wait, hold on. It was, okay, this is -8. And they're counting by 2s here. So this is -2, -4, -6. So it is, it's here at -8. This is -10, I guess. And it goes up 1, 2, 3, and over 1, 2, before it hits another, I guess, cross section on that graph, you know? So that's going, if it's counting by 2s here, that means it's going up 2, 4, 6, really, up 6 and over 2. Because on the y-axis is counting by 2s, the x-axis on here is counting by 1s. So that means it's 3. The slope is 3. And context-wise, if that's miles per minute, if I multiply that, so this is miles per minute, that's how fast he's going, or times 60 would be 180 miles per hour. So he's going pretty fast. Then it asks, is the graph increasing or decreasing? Well, it's increasing because he is, the car is traveling northeast. That's just directional. It's just a positive slope. It's traveling northeast. And over what interval is the graph negative? If you look at that picture, you can kind of see that it starts off, you can kind of see here it starts off down here, and then it crosses at 2.5. It crosses the x-axis at 2.5. So for x less than or equal to 2.5, 2.5, it's negative. And what does that mean? It means the car basically is approaching the cop. Okay? So we can say, meaning the car is approaching the cop. He's south of the cop. Okay? So that's how you do those. You're going to have one situation. Number two, you're going to have a negative slope. Okay? So if you look at that, and remember, negative slope just means it's something directional, meaning like he's traveling southeast. Okay, so that's just the only difference for that one. And then on the third one, you're going to have, I can't even see like what it says there, but we'll just make up something for this. I can't see it, but let's say this says, I think it says, Cobo Hall. I'm not sure what it says, but there's, just make up a scenario for that one. Maybe a car driving past an important landmark or something. And he's driving toward it. Okay. And, it's going to be an increasing graph, and kind of similar to the one we just did, except instead of like I said, instead of a speeding car and a cop, it might be a car traveling to sightsee, and he's passing some kind of important monument or something like that. So anyway, now the next section. So that was step 1. Oh, actually, there's one more example I want to show you. On step 1, it says to graph the following scenario. Okay, so I'm going to do one of these, and then you'll do the other one. So sketch a graph of a function that has all of the following characteristics. So I'll do it on this graph. Okay, so it says it has an x-intercept at 3, 0. So first start over here, 1, 2, 3. Remember, this is the x-axis, so that's why I'm going along this line. So the x-axis, that means, again, this is an x and a y point. I go right 3, and I don't go up. I just put a dot there. It has a slope of -4. So remember, -4 can be written as -4/1. And that tells me to go down 4, right 1. I can also go, if -4 can also be technically written as +4 over -1, so I could go up 4, left 1. So either one. Okay, so those are the two ways you can go. So I'll go down from this point, go down 1, 2, 3, 4, and right 1. So that was -4/1. And again, I can do that again if I want, or I can go from here and go the other way using this one. So up 4, left 1. Up 1, 2, 3, 4, and left 1. And then I can draw my line through it. Okay, so this is where you kind of want a ruler here, but it's pretty steep. But you draw a line through it. Okay, there's your line. And now you're going to do the other one. Again, so all of that is part of step 1. So then you have a second step. This one's going to be nice and easy. So step 2 is nice and easy, and this is an example of it. And I think you could do all 3 of these on your own. I don't think I'll need to do one, but I'm going to do one anyway. So on here we have speed versus distance, which is a little bit different. Before we had distance and time. Now we have speed and distance. So this graph's going to look a little bit different. So it says here, suppose a car travels for 10 miles at 40 miles per hour. Then it speeds up to 60 miles per hour for 40 miles. Then it slows down to 30 miles per hour for 10 miles, and then it stops. We would make a graph and use miles for the x-axis and speed for the y-axis. So all you have to do is start at that first situation. So suppose a car travels for 10 miles at 40 miles per hour. So if this is distance, here's the miles. He goes 10 miles and he goes at this speed. So you actually go to 40 miles per hour, go up to that, and then just go out to 10 because he went 10 miles. After that, it jumps up because now he's going 60 miles per hour. So now he's up at the 60 for speed. And he goes for 40 miles. So what you have to do is, right now we're at 10. So add 40 to that. So 40 plus 10 is 50. So that's why they went a total of 40 units over, and they stopped at the 50. Okay? So then that's where that would go. So you draw your line there. And then it says it slows down to 30 miles per hour. So now we go back down here at 30. And it goes for 10 miles. So we go 10 units more. 10 units total more. And then after that, it stops. So we just put a dot for stopping. Because it doesn't go any distance. It's just stopping there. And it's if it stops, it's also going to be down here at 0 miles per hour. So that's all you have to do. And then there's 2 of these. I think I just gave you guys 2 of these. So so again, for this situation, let's do this second one. You do the first one, okay? It's kind of similar to the example, and we'll do this second one. A car is stopped for 1 hour, so it's not going anywhere, okay? So we just put a dot right here. All right, it's stopped for 1 hour. Then it begins to drive for 2 hours at 30 miles per hour. Okay, so on this one, and honestly, I think this should actually be a different kind of graph. So because if we're talking about, we're not graphing, on this one I think they gave you the wrong graph. They're not graphing speed versus distance. We're actually going to be graphing, it looks like speed and time. So technically this should be changed to time. Alright, let's try this again. So a car is stopped for 1 hour. So in this case, its speed is 0, and it's an entire hour. And again, we kind of I need to redo this graph. So let's just go up to the top one, and I'll fix the graph. So this one, create a graph of the following situation: a car drives at 20 miles per hour for 5 minutes. So 20 miles per hour for 5 minutes. So it goes to here. Okay, 20 miles per hour, 5 minutes. Then it drives 80 miles per hour, so we're up here, for 50 miles. So we got to count out from 5 all the way to 55, because that's 50, a difference of 50. So we got to draw this all the way over. Okay. Then it slows down to 20 miles per hour. So now we got to go back down to 20 for 5 miles. So we're just going to do one little unit there. Oops, actually it should be over here. So for 5 miles, and then it stops. So it's just going to stop right there. Okay? So that's how you graph that one. Again, don't graph this part. Did not mean to do that. Just kind of didn't see that. But yeah, so it's just this right here. Just that little 5 unit length right there. Okay, and then you stop. Okay, so you're gonna try another one like it. I'll redo that one, and you do one that's like this one. Okay.